I have talked about two concepts. One is center of mass and how to find it. Second is analogy between translatory motion and rotational motion. Two topics only I have taught. Now focus here, okay? So I'll just give a quick recap about whatever I have taught before I go into the class today. So in the previous class we have learned about center of mass. I said center of mass is the point on the object or outside the object where the whole mass of the body is concentrated. So if you take any object, it will have a point where we can balance it. That point is called as center of mass. That point may lie on the body, that point may lie outside the body also. Sometimes question comes in the examination, they will mention that in which of the cases center of masses lie outside, and they will give 4 options. So you can judge by yourself. Suppose I give options like one body I have drawn in this diagram, one is this, and another one is this. In which case the center of mass will lie outside the body? Option D, 4th one, isn't it? Because very clearly visible that 1, 2 and 3 center of mass will lie somewhere in its geometric center. And here also it will be geometric center, but geometric center is not lying inside the body, it is a ring. Same way if I draw a diagram like this, like a crescent, or if I draw a diagram like this. In all the scenarios, the center of mass is going to lie somewhere outside its surface. It won't lie on the surface, right? So that's what center of mass is. But one thing, pay attention. If suppose I connect some plane here and then I locate the point, then this point comes in center of mass. So don't think center of mass cannot be created for an object. It can be created also if you additionally add some mass on that. So basically center of mass is a center where the object gets balanced. I hope this is clear to you. In the previous class, last class we learned how to find the position of center of mass, and I said you the formula as RCM, that is position of center of mass, as M1 R1 plus M2 R2 Mn Rn by M1 plus M2 plus M3 up to Mn. And we even solved some questions in the previous class to understand how this formula is applied to get the position of center of mass. So I think 3-4 questions we took in the class, and that questions would have made you understand how it can be asked in the examination. Then we learned about analogy between translatory motion and rotational motion. There I told you, in translatory motion, whatever formula you have studied, once again I am repeating that because today's class will start from there only. For example, in the first chapter you have studied about V is equal to U plus AT, or if you write S is equal to UT plus half AT square, or you write V square is equal to U square plus 2AS, or you write force is equal to mass into acceleration, or write momentum is equal to mass into velocity, or you write force is equal to rate of change of linear momentum, or you write power is equal to force into velocity, or you write work done is equal to force into displacement, isn't it? All of these formula, or kinetic energy also we wrote yesterday. Kinetic energy is equal to half mv square if u is equal to 0. So all these formula that you have learned in the previous chapters, chapter 2, 3, 4, 5, 6, all the formula, whatever you have learned till now, everything has a rotational counterpart. And how to understand that? I said you have to do some replacements. For example, we will replace the displacement with angular displacement. S we will replace with theta. We will replace u with omega naught, which is initial angular velocity. We will replace v with omega. We will replace acceleration with angular acceleration. We will replace mass with inertia. We will replace force with torque. We will replace linear momentum with angular momentum. That's all. So all these replacements when you make in these same equations, you will get the equations that we are going to use for rotational mechanics. For example, we will write here, instead of this we can write omega is equal to omega naught plus alpha t. We can write theta is equal to omega naught t plus 1 by 2 alpha t square. We can write omega square is equal to omega naught square plus 2 alpha theta. We can write tau is equal to I alpha. We can write L is equal to I omega. We can write tau is equal to dl by dt. We can write power is equal to tau into omega. We can write work done is equal to tau into d theta. we can write rotational kinetic energy as half I omega square. All these things we have learned in the previous class. What?
Radians per second.
Yeah, I'll tell that also. That is, whenever you are taking displacement in SI unit, you are taking meters. Same way in rotational mechanics, whenever I will take displacement, I will take in radians. Angular displacement will be taken in radians, not in degrees. Same way, omega naught will be in radian per second, isn't it? Even omega. Alpha will be in radian per second square. These things I'll tell you what are the units for these when we learn these topics. That is moment of inertia. Today we learned that moment of inertia, torque and angular momentum. What are the units? I will talk about that. But based upon this, one question we saw in the previous class. Before I wind it off, one question only we saw in the previous class. Today, let us start today's class with one more question from analogy. Then we will start today's topic, which is moment of inertia. So take one question, make it fast. Everybody, take one question. Shall I? Simple question. Angular velocity of second hand of a watch. What is the angular velocity? What is the angular velocity of second hand of a watch? I'll repeat. What is the angular velocity of second hand? SESCOND, second, that's second hand of a watch. That's the question. You have to find what is the angular velocity of second hand of a watch. Nikhil, Ritika, Soumya, video should be on if you are in the online class. How many times will we say that? One radian per second cannot be the answer. Somebody has told the answer as 1 radian per second. Cannot be. 6 radians per second. No. Radian by 60. What is the meaning of that? Radian is a unit, man, not a quantity.
Sir, pi by 60.
Pi by
60
radian per second. Pi by 60 radian per second is wrong. You are in some other universe. 5 by 30, how, man?
Pi by 30, no sir, pi.
Pi by 30 radian per second. Correct.
Pi
Good.
by 60.
You told pi by 60, no? It is wrong. Pi by 30 is correct. Common sense, yeah. See, second hand, Bharatraj, please. Second hand, it will complete one full revolution in how much time? 60 seconds, isn't it? And how much angle it covers? Degrees. In radians, 2 pi radians, right? Pi plus pi, 2 pi radians. So what will be the velocity? 2 pi divided by 60. What is that? Pi by 30 radian per second. Are you getting my point? So how the answer came pi by 30 is clear to you? Very simple question. We can solve without even using pen. I will once again repeat it. So if you see a second hand takes the complete revolution in how much time? 1 minute, 60 seconds. And how much angle it takes? Degrees. In radians, how much? 2 pi, isn't it? You know, 1 pi is 180, right? 2 pi is 360. We want to find angular velocity, if I am right. So angular velocity will be angular displacement by time. What is angular displacement here? 2 pi. How much time it takes? 60 seconds. So it will become pi by 30 radian per second. In the same question, if I ask you, what is the angular velocity of minute hand? What will be your answer? Same question, if I say, what is the angular velocity of minute hand? Will the answer remain same? No. It will change. How much it will become? It will become 2 pi by how much time it takes? Minute hand. 1 hour it takes, isn't it? 60 into 60. Correct. So 60 into 60. So which will become pi by 1800 radian per second. Is it clear to you? If I ask you hour hand how much? 2 pi divided by 24. Where Sri Krishna is having a watch which has 24. And I am saying 24 hours how, man? Any watch you have seen 24 hours on the watch, all 12 hours will be there. Don't forget this, man. It is common sense. In a watch, how many hours you will have? 12 hours only. In a day we have 24 hours, but in watch you don't have 24 hours. Any watch came like that? I don't think. So it will be starting from 12, isn't it? What, Krishna? Understood what mistake you made? So it will be 2 pi divided by 12 times 12 hours. Each hour is having 60 minutes. Each minute is having 60 seconds. This much radian per second. Are you getting my point? How to solve this kind of questions? Second hand, how it came pi by 30. Minute hand, how it came pi by 1800. And hour hand, how it is coming by this much, whatever it comes. Is all by the basic common sense. What we are calculating? How much time it takes to complete one revolution, and we are dividing 2 pi by that value. If I ask you, what is the angular velocity of Earth rotation? What will be your answer? Earth's rotation, what is angular velocity? Is my question clear? 60,000 meter per second. Your which?
Sir, that's speed only it rotates, no, sir.
I am asking angular velocity of Earth. Radian it should come. Once again, Earth will take the entire rotation in how much time? 24 hours. And how much angles? Once again 2 pi. So 2 pi divided by how much? 2 pi divided 24. Now Shri Krishna answer came. What question I asked? 24 times 60 times 60 will give you the angular velocity of whom? Of Earth. Rotation. If I ask you, what is the angular velocity of Earth's revolution? 365 days into 24 into 60 into 60. Are you getting how the logic is being used? We are calculating total angle. Tell me, something you are asking? Very good. So angular velocity varies for, yeah, actually you are right. Don't worry about that. First understand this much. Okay. So if we are able to find how much angle is taken in how much time, you can easily calculate the angular velocity of an object. Is it clear to you? I hope it is clear to you. Let us start today's class and give the heading as Moment of Inertia. This was just the previous class continuation. Today we will learn the topic, give the heading as Moment of Inertia. Moment of inertia. Okay, by God's grace, in NCERT they have reduced lot of portions from moment of inertia, which is the most complicated part of this chapter. Everything else is simple as of now, what you studied till now. Center of mass, if you are listening properly, it is simple only. Analogy also is actually simple only. But from here the trouble starts, and luckily they have removed 70% of the portions in the CBSE recently. And what remains is very small things, so it will become easy again. So moment of inertia plays the same role as played by mass in translatory motion. Write this statement first. Moment of inertia plays the same role. Moment of inertia plays the same role as played by mass. In translatory motion, as played by mass in translatory motion. Okay, now please pay attention. So first of all, understand that moment of inertia will be applicable only if the body is under rotational motion. Clear? If the body is at rest, don't think about moment of inertia. Moment of inertia can come only if the body is rotating. And moment of inertia depends upon two things. One is mass, another thing, distance of the mass from the axis of rotation. Listen to my words very carefully. Moment of inertia depends upon two things. One is the mass of the object. Second is distance of the mass from the axis of rotation. So, first of all, to understand moment of inertia well, you must have an idea about how the object is rotating. Is it rotating on its own axis, or is it rotating around a particular axis? For example, I may have a rotational axis and I may have a mass, and this mass is rotating like this. It is m, this is r. It is also possible that I have a mass and it is rotating about its own axis. Possible, right? I may have a condition where I am having a square lamina and it is rotating like this. Possible? How it is rotating, you are able to feel, no? Like you can put a notebook and rotate in your hand. I can have the same square lamina and rotating like this. How it will rotate? Like a flag rotating on a pole. So, each case, how the body rotates determines what will be its moment of inertia. So, first thing, you should be very clear in axis of rotation concept. If you are failing in that, you cannot understand what is moment of inertia. So, whenever I say axis of rotation, you should be able to understand, okay, this is the axis of rotation. And how we define axis of rotation? By using simple terms like object is rotating about an axis perpendicular to its plane, passing through its center, parallel to its plane, passing through its tangent, like that we will say. So, when I say something, you should observe, listen, and then draw a conclusion how the body is rotating, because the same body can rotate in multiple ways. So, until you understand how the body rotates, you cannot think about finding moment of inertia. Okay, we will go to that later. First, understand what is the definition of moment of inertia. It plays same role as mass. This question has come in the school exam many times. In many times in school exam, they will ask you, what is the analogy of mass in rotational mechanics? What is the answer? Moment of inertia. Okay. Now, what is moment of inertia? Write a definition. It is defined as the product of mass and square of the perpendicular distance, square of the perpendicular distance of the mass from the axis of rotation. Mass from the axis of rotation. From the axis of rotation. Now, what does it mean? Please pay attention. Here I am having a mass m and the axis of rotation has a distance of r from this mass, isn't it? If you read the definition properly, you will realize that I have told moment of inertia is the product of which two quantities? One thing is mass, another thing is square of distance. Which distance? Perpendicular distance from the axis to the mass. So, the basic definition of or basic formula of moment of inertia is what? Mr square, where m is the mass, r is distance. Which distance? Perpendicular distance of the axis of rotation from where the mass is there. Suppose I am having multiple masses. For example, if I am having the rotational axis, at distance r1 there is mass m1, at distance r2 I have mass m2, I have distance r3 I have mass m3, like that I have r4 and I have m4. Like that, assume that there are multiple masses m1, m2, m3, m4, m5, and all the masses are rotating around the same axis of rotation. Then what will be the moment of inertia? Then the moment of inertia will become equal to m1 r1 square plus m2 r2 square plus like this mn rn square. Are you getting my point? Very basic thing I am telling you. If you have multiple masses, all the masses individual moment of inertia can be added to get the net moment of inertia. That is why I said moment of inertia can be determined only if the body is in rotation. If the body is not rotating itself, then how can you find r? Are you getting a point? Since the body is moving like this, only you understanding, okay, this is the R value. If the body is at rest, whether R is this or this or this, we don't know. So we cannot determine the moment of inertia until the body comes in motion, rotational motion. So moment of inertia can be found only if the body is in rotational motion. If you have understood this, please copy it fast, this formula. Tell me, man.
What the different masses are with the same radius, that means same distance?
Then the same thing, it will become m1 r square plus m2 r square plus m3 r square, take r common, then r into m1 square plus m2 square plus m3 square, like that. Sorry, ulta I am saying, r square into m1 plus m2 plus m3 plus m2, like that. Okay. Make it fast.
Sir, if a same mass is rotating around two centers,
If the,
so like two centers it is orbiting like this.
how can it have two centers, man? It can only, what you are drawing is ellipse now. It's not circle itself. Are you getting? If it is having two centers, it cannot be circle. No, it can be not rotation. It can be like it is revoluting around two focus. We will talk about that in gravitation. Have you copied it? Make it fast, please.
R changes, R changes, mass.
Then moment of inertia also will change, because moment of inertia depends upon R. Are you getting? If suppose what a question is, see once again what he is asking, Ashwath. Suppose there is a mass and the mass is rotating at R1. Slowly the same mass, within some time it goes to new distance R2. Then its moment of inertia also will change. Are you getting? Suppose this is the body, and the body is moving like this, going far, 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 far. Its moment of inertia also changing. Are you getting? Because moment of inertia is depending upon this R. If this R changes, then moment of inertia also changes. Is it clear to you? Okay. So, have you copied this? Okay. Now, let me, you have NCERT book in your hand? Everybody? If you have, you open it, or else I will also open it here. That day also we opened this book, no? Yeah. In NCERT, if you see a table, whether they are or they are removed, many things they have removed from there. Is it visible to everybody? Page number you see, no man? 116. Are you able to see this diagram on the board? Pritish, visible? Okay, now please pay attention. This thing, what I am going to tell now, is maybe less important for this class, but highly important for Sunday's class. Because this will convert into a very big concept in parallel axis theorem and perpendicular axis theorem, which is not there in school syllabus now. So if you fail to understand this today, you will have problem in Sunday's class also. So please understand it well. Nothing is there. What is there? There are, I think, 7 conditions given, 8 given. So basically, you should remember the value of moment of inertia for these 8 conditions. What are these conditions? The first one is thin circular ring. I hope you understand what is the meaning of ring. It will have some hollow in space in between. So if the body is a thin circular ring of radius r, having its rotational axis perpendicular to plane passing through its center. So you can imagine how the body is rotating, like this. You are able to feel how it is rotating. So in this case, the moment of inertia is mr square. M is its mass, r is the radius. Leave this we can derive. If you want, we can derive this thing in commutative class. See this, if I am having a thin rod of length L and the rotational axis is passing perpendicular to the rod at midpoint. This is the rod, it is passing like this, it means how the rod is rotating, like this, isn't it? You are able to feel the rotation of rod? It will have a moment of inertia of ml square by 12, where L is length of the rod. Same way, if I am having a circular disc, disc is different from ring. Disc means like a plate in which you are eating food, that kind of plate, if you are eating in round plate. So, that disc and the same rotational axis is passing perpendicular to the disc at the center. What is the moment of inertia? Mr square by 2. This not to remember, I will derive it by using theorems in the commutative class. For the people not coming to commutative class, they can remember it. But for commutative students, I will teach a theorem which will help you in deriving it very easily. So, you need not to remember all this formula. What you should remember is this ring perpendicular to the plane, this thin rod plane, circular disc plane, and this hollow cylinder. Hollow cylinder, what is the value? Mr square. If it is passing through where? Axis of cylinder. If it is solid cylinder, Mr square by 2. If it is solid sphere, 2 by 5 Mr square. Okay? Maybe we will have hollow sphere also, but not there in your syllabus. Again, Sunday it will come. It will change. They have not mentioned here. Very limited thing. I don't know, many things they remove from syllabus. But in Sunday's class, we will learn all these things. How to find for all condition, not one condition. I will teach you how to find for this. I will teach you how to find for the tangent. Suppose the thing rotates like this. Then how to find moment of inertia. We will learn all these things in Sunday's class, but not required here. Okay? So now everybody please write this in a notebook. Which one you will write? You write for this number 1, number 3, number 4. Copy this up fast. Make a table and write 1, 3, 4. Heading is moment of inertia of different bodies. Moment of inertia of different bodies. Moment of inertia of different bodies, and you can make the same tabular column. You can write the body, you can write the axis of rotation and the moment of inertia. Figure if you want, you can draw your wish. And draw it for 1, 3 and 4 fast. 1, 3, 4. If you want, you can draw even for 2 if you want. But 2 I will be deriving in Sunday's class. Have you written for these 3? Mr square, ml square by 12, Mr square by 2. Can I go below? One, 2 and 4 is compulsory, third is optional. If you want to write, you can write. I don't have any problem in that. Can I come down? you can skip 5, but you can write 6. If you want to skip 5, you can skip 5, but write 6 and 7. Because once again 5 I will derive in the class. Six is for a hollow cylinder, and the rotational axis is passing through the axis of cylinder. Mr square is the value. Copied? After 3, I said 4, I said 6 and I said 7, and obviously 8 also. Have you copied? Done. Can I go to the board once again back? Please fast, please fast. Careful, Rajane, don't sleep. Shall I? I'll write once again all these things on the board. That time you can copy if you want to copy. So if you notice, one way I'll tell you to remember. See, if you notice, you will realize that for ring and for hollow cylinder, what is the moment of inertia? You notice that? Same way, if I am having a disc and if I am having a solid cylinder, then how much is the moment of inertia? Mr square by 2. So you can remember that if something is hollow, so this is also hollow disc only, this is also hollow cylinder only, it becomes Mr square, and if it is solid, that is disc or cylinder, the moment of inertia is Mr square by 2. If it is a rod and length is L, then it is ML square by 12, and if it is sphere, which is a solid sphere, should always mention the rotational axis properly. Yeah, if it is a solid sphere, then the moment of inertia is 2 Mr square by 5. One more thing which is not there in NCERT book but may be required for you, can be the hollow sphere like football. So if it is hollow sphere, then it is 2 by 3 Mr square. 2 by 3 Mr square. Yes.
Ring which is rotating in its diameter is also 2 m r square by 2.
We will derive that later. Okay. But these things are very basic things you should remember. 1, 2, 3, 4, 5, 6, 7. It must be there in your head. Whenever I ask, you should be able to tell me. If I ask you, there is a solid cylinder which is rotating about its axis, what is the moment of inertia? You should say mr square by 2. If I ask you, if a ring is rotating about an axis passing perpendicular to its plane and through its center, you should be able to say it is mr square. If I say solid sphere rotating, axis of rotation passing through its diameter, if it is solid sphere, 2 by 5 mr square. Hollow sphere, 2 by 3 mr square. For rod, ml square by 12. So these 6, 7 values, and in all case, remember what is the value of r? R is the radius, okay? R is the radius of this thing, objects, okay. So now give the heading as radius of gyration. I hope some of you would have studied this already in your school and you would have not understood anything in this, because radius of gyration can be very confusing. I will confuse you more. Take the definition first. Take the definition. Yeah, if you write a definition, you definitely will get confused only. Definition is radius of gyration. Please write radius of gyration of a body. Radius of gyration of a body. Radius of gyration of a body about a given axis. About a given axis is the perpendicular distance. About a given axis is the perpendicular distance of a point from the axis from the axis where if the whole mass of the body is concentrated, where if the whole mass of the body is concentrated, where if the whole mass of the body is concentrated, the body shall have the same moment of inertia. The body shall have the same moment of inertia as it has with the actual distribution of mass, as it has with the actual distribution of mass. I will repeat the same thing. Those who could not write properly, once again I am repeating. Radius of gyration of a body about a given axis is the perpendicular distance of a point from the axis where if the whole mass of the body was concentrated, the body shall have the same moment of inertia as it has with the actual distribution of mass. Wrote? All of you wrote? Understood? I said no. It can be very confusing. I don't. Anybody can tell what you understood from this? I don't think anybody will be able to say. It looks very confusing. Each statement looks like what is this? Same thing, repeating. Moment of inertia. Word is repeating multiple number of times, isn't it? Give me 10 minutes. I'll explain this to you. Then you once again read the same definition. It will be clear to you. But 10 minutes focus here. What I am saying. Okay. So first of all, radius of gyration of any body is about a particular axis. Okay. Now, for example, I will take an example and explain you. Suppose I am having a disc. You know very well by now what is the moment of inertia of a disc. What is the value? m(r square by 2). You know this. Okay. What I do, I take this disc, I crush it and I make into a small ball. Pay attention. What I do, I take this disc, crush it and make into a small ball. Do you think the mass will change? No way. Its volume may change, volume also will not change, its area will change, its shape will change, its mass will not change. Do you agree with me? Same mass, I just confined it and made into a small ball. And what I do, I try to find how much distance away from this, if I rotate that mass, it will have the same moment of inertia of mr square by 2 only. I will repeat this. I will repeat this. I will tell 10 times also, no problem in that. Assume that its mass is 1 kg, its radius is 1 meter, just for the easiness. How much is the moment of inertia? Moment of inertia is 1 into 1 square by 2, which is equal to 0.5. What is the unit here? Mass into radius square. So it will be kg meter square. Per by here, kg meter square. No, per will come here. Kg meter square is the unit of moment of inertia. So I got the value as 0.5 kg per meter square. Now you have 1 kg mass. This 1 kg mass, you should find at what distance if I start rotating, it will give me 0.5 kg meter square. You can say now itself. If I go see what is the formula of moment of inertia, general formula mr square, isn't it? General formula is mr square. So if I am having inertia value as 0.5, if I am having mass as 1, I can easily find what is the value of r. R will become equal to, what is this? 1 by 2 root over, isn't it? It means if I go 1 by root 2 meters away from center and rotate the body, moment of inertia will be same 0.5 kg meter square only. Are you getting my point? Not getting, no, I will explain 10 times, don't worry. Today you will understand and go home, or you will not go home. Something will happen. I will repeat once again. So what I do, I am having a disc, pay attention, okay? I am having a disc. Disc is having 1 kg mass. Disc is having 1 meter radius. What is its moment of inertia as per the formula? If it is rotating on an axis passing perpendicular to its plane and through its center, moment of inertia value is 0.5 kilogram meter square. Understand this much? How this came in understanding? Okay. Now, what I do, I crush this disc and I make it into a ball of mass, same mass will not change, 1 kg only mass will be. And now this ball, I am trying to rotate and find, see if I rotate at 1 meter from here, what is the moment of inertia? 1 into 1 square, which will be 1 kilogram per meter, kilogram meter square. If I rotate at 0.5, it will be 1 into 0.5 square. Like that, I will find where I should rotate so that my moment of inertia becomes same 0.5 kg meter square only. That distance is called as radius of gyration. It is the distance at which, if the whole mass of the body was concentrated, the moment of inertia will be same as the actual distribution of mass. I will explain once again.
Sir, initial radius equal.
How, man? Check, I gave example to you also. This formula is mr square by 2, Tambi, and general formula of moment of inertia is mr square. In this case, if I take direction as k, it is denoted by small k, I can write mk square here. The k value came as how much? 1 by root 2. One more example I will give you, pay attention. Those who are confusing, please be a little more attentive. Now what I am taking a ring. Okay. This ring is having a mass of, suppose, 2 kg and having a radius of r of 1 meter for easiness of calculation. What will be its moment of inertia? mr square, isn't it? mr square means 2 into 1 square, no? So answer is 2 kilogram meter square. This is moment of inertia of a ring of mass 2 kg rotating about an axis passing perpendicular to its plane and through its center. See, every word is important in today's class. If I want to find a radius of gyration for this circular ring, what I will do? The same ring, I'll crush into a mass. How much mass I have? 2 kilogram mass I have. I want to find this 2 kilogram mass where I should rotate so that my moment of inertia becomes same 2 kg meter square. Isn't it? And the formula of moment of inertia is how much? Mk square. In this case, because k is the radius of gyration. So what is the value of k I want to find? Moment of inertia is how much? 2 known to me. Mass is how much? 2 into k square. 2 gets cancelled. Here it came as 1 meter. It means if I rotate at 1 meter, I am going to have the same moment of inertia as there in actual distribution of mass. One more example I will give you. Assume you have a hollow sphere. Please pay attention. Without understanding, you should not go today. I am having a hollow sphere. If there is a hollow sphere, I know its moment of inertia formula is 2 by 3 mr square. Let its mass be 2 kg. Let the radius be, take 2 meters this time for difference. Okay. Now what is the moment of inertia? 2 by 3 into 2 into 2 square. How much you are going to get? 2 to the 4, 4 to the 16, 16 by 3 kilogram meter square. Do you understand this? Now I want to find its radius of gyration. What I will do? This hollow sphere like football, I am going to remove all the air, crush into a small ball, mass will remain same, and now I am going to rotate and check where should I rotate so that my moment of inertia remains 16 by 3 kilogram meter square only, and whatever distance you get that value, the distance is called as radius of gyration. So by that formula, I, which is equal to mk square, I value is known to me now, how much? 16 by 3. What is the mass here? 2. Then I can find k square. What is the value of k? K will become equal to root over 8 by 3. Whatever you get, leave that. No need of checking math here. Enough. If you are able to find this distance, you will be able to know, okay, at this distance, if the mass is concentrated and rotated, it will have same moment of inertia as this system. Now read the definition once again. Sai Varshini, you read it loudly.
Radius of gyration of a body about a given axis is the perpendicular distance of a point from the axis where if the whole mass of the body is concentrated, the body shall have the same moment of inertia as it has with actual distribution of mass.
Something you are understanding now? Is it clear to you? So it is that perpendicular distance where if the whole mass of the body was concentrated, it will have the same moment of inertia as it has in actual distribution of mass. Understood or not? If you understood, means whole class understood now. More example you want? Understood? Sure. It is just a distance, man. At that distance, if the whole mass is concentrated, it will have same moment of inertia as it has in the actual distribution of mass. That's all. Are you getting? Now what we can do, please guys, not over. Now what we will do, for all these shapes, we can find and generalize what is the radius of gyration. Easily we can. How we can find? The I is known to you, and I is also equal to what? Mk square, isn't it? I is equal to mk square also. If you equate both, here you will get k is equal to r, isn't it? So it means that for ring and for hollow cylinder, the radius of gyration is always equal to its radius. For a disc and a solid cylinder, let us check. We will equate I is equal to mr square and I is also equal to mk square. So I will generally equate it. I will write mk square is equal to mr square by 2. Gets cancelled. K will become equal to r by root 2. So by using this formula, you can find radius of gyration of a disc or a solid cylinder rotating about an axis, in this case axis of rotation, here perpendicular plane and passing the center. For this shape, sorry, this will not have radius of gyration. For this shape, 2mr square will be equated with what? Once again mk square, directly I am doing it. Gets cancelled. So k will become equal to root of 2 by 5 into r, isn't it? And for here what you will get value of k? Root of 2 by 3 into r. Do you understand this? I have written the radius of gyration of all the shapes. Here k is equal to r, here k is equal to r by root 2, here k is equal to root of 2 by 5 into r, here k is equal to root 2 by 3 into r. This topic, now I have taught you, most of you hopefully have understood. Tomorrow you will forget it. Today if you don't go back to home and solve some questions based upon this, you will definitely forget it, believe me. So please have understanding that these topics can be clear only if you practice a lot of questions from here. Is it clear to you? So first copy this, whatever I told now.
Sir, what is the real life application?
Many applications are there. The whole mechanical engineering is there, no? By which we design a lot of machineries, cars, aeroplanes, everything. Everything is based upon rotational mechanics only. Because we have so many rotating parts in that. Car has so many rotating parts, have you seen? Engines have so many rotating parts. So where the rotating part comes, there you should know about all these things. You will not understand it now, but when you go to college, no? If you go to college for studying engineering, and if you take mechanical engineering, these things will play a very important role. One book will be there, Rotational Mechanics. One semester, one book will be there. Okay? So you want to write these examples also, if you want, you can write. You want to write these examples? Not required, no? Okay, very good. Write this at least. Yeah. Definition? Simple, huh? So that is the correct definition, man. If you want to write in simple words, you can write in your own way also. But the meaning is that only.
Sir, he's saying that this definition is taken from mechanical engineering.
Not like that, man. School level only this is.
Sir,
Yeah, please.
sir, could you please derive the moment of inertia for thin circular ring, sir, to just get an idea how it's actually derived?
Circular ring I have done here, no? You are saying the derivation of mr square. I is equal to mr square, you are saying.
Yeah, sir.
I'll do it, man. First you copy this. We'll do that. Have you copied this first of all? Make it fast. Done. Copied. Boys behind Sharad. Done. Make it fast, please. Done? I hope you have done. So, guys, once again, as I said, today the class has to get over early. Shoaib, I will do the derivation in the next class, okay? Next class, I will start my class with the derivation of this thing, what you have asked me, okay? It will take some time. So, everybody else, please pay attention. Today, what we have learned, after solving some questions based upon the analogy of translatory motion and rotational motion, we learned what is the meaning of moment of inertia. and moment of inertia is the product of mass and square of rotational axis distance or radius square, whatever you say it. Then we learned the moment of inertia of some shapes. For example, a ring, a disc, hollow cylinder, hollow sphere, solid sphere. Only for the axis which is passing through its geometrical center, I can say, isn't it? Any other axis, how to find moment of inertia will be taught only in the commutative section. It is not required for school, like passing through diameter, passing through the tangent to the radius, all these things we will be discussing in the Sunday's class. Then we learned what is the meaning of radius of gyration, and we understood that radius of gyration is a distance of the or from the rotational axis of a point where if whole mass of the object is concentrated, the moment of inertia will be same as it has in actual distribution of mass. And we found the radius of gyration of different shapes. For example, for a hollow ring and hollow cylinder, it is k is equal to r. For solid ring, that is disc, and solid cylinder, it is r by root 2. For a solid sphere, it is root 2 by 3 into, solid means 2 by 5 into r, and for hollow sphere, root 2 by 3 into r. So, all these things you have seen in today's class. Go home, relearn all these things and solve some questions based upon this from the NCERT book. If you want some questions, I will send in the group also. Solve some questions and we will continue the next class. Is it clear to you? So, we will wind up today, we will meet again.